So as part of our class activity today, we're going to go through pages 1, 2, and 3 of the 4 pages. The 4th page will be left for homework. So for those of you listening to the video, if you are in person on Monday of next week, we will quickly discuss the first 3 pages and then go through the 4th page as a class. So the problem number 1, you're asked to plot 3 points, one at 0, 0, which is A, one at 3, 4, which is B, and one at 3, 0, which is C. From here, you're supposed to use the rule xy goes to 2x, comma 2y, and then locate points A prime, B prime, and C prime. So if you have not done that yet, go ahead and turn the video off, complete that, draw that triangle, and then answer the questions that come underneath problem 1. So the first problem 1A is asking, do the corresponding angles have the same measure? And so for those of you who were not here today but are at home, on Tuesday when we met, I asked you to take the handout plus some patty paper with you. And so using the patty paper, you would check to see if the angles are the same and answer the question. Hopefully you've already done that, but angle angle C and C prime, same measurement. Angle A and A prime are going to be the same measurement because it's the same angle. And therefore, angle B and B prime better be the same measurement because the sum of the angles of the triangle is 180. So they both share right angle with C prime and A prime are the same angle, and the other 2 angles have to be the same. The question here is, do the corresponding angles have the same measure? Absolutely. Are the lengths AB equal to the lengths of, how many ABs does it take to equal A prime, B prime? How many ACs equal A prime, C prime, as well as CB and C prime, B prime? Hopefully you found that the number is 2. So that would be from AB be the first one, and then B to B prime would be equal to each other. AC and CC prime are both 3s. And BC is a height of 4, and B prime C prime is a height of 8. So in all cases, hopefully you found that the lengths doubled. If you're thinking about that rule that you were asked to use here, is the rule itself will also tell us that these lengths should double. Find the length of each side of the triangle, and then find the perimeter. And then do the same thing for A prime, B prime, C prime. And then the question is, how many perimeters does it take? So for the original triangle, AC is 3, and BC is 4. If you use the Pythagorean theorem, since this is a right triangle, you will find that AB is 5. For A prime and C prime, that length is 6. For B prime, C prime, that length is 8. And again, using the Pythagorean theorem, the length of A prime, B prime is 10. So the original perimeter is 3 plus 4 plus 5, which is 12. And the second perimeter is 6, 8, and 10. So that perimeter is 24. So how many perimeters did it take? Hopefully you decided it was 2. But the second triangle, A prime, B prime, C prime, has a length that's pretty much twice as long. All right, so the common factor that we use is called a scale factor. So anytime we're enlarging a shape, and we're talking about lengths now, doubling the lengths, tripling the lengths, we call that a scale factor or a zoom factor. Your textbook uses scale. Other textbooks use zoom. The reason for zoom is they think about a camera. When you have a camera with a lens on, you can zoom in. Scaling something is a more traditional word. In both cases, we're using the word factor, which goes back to elementary school. When you did factors of numbers like 12, the factors of 12 are 1 and 12, 2 and 6, and 3 and 4, because each pair of numbers when multiplied together equals 12. So factors implies the multiplication problem. So they're asking you problem number 2, which of the following shapes are enlargements of shape A? If the shape is an enlargement, state the scale factor. So for example, I want to compare A and B as an example, and then turn the video off once I'm finished with B, and then take a look at C, D, and E, and decide are those shapes also scaled copies of A. So on A, the height is a 3, this length is a 1 going across the top, coming down is 2 over 1, and then the bottom is 2. So if it truly is a scale, I should be able to see that the length of 3 going up, and the bigger one is going up 1, 2, 3, 4, 5, it's going up 6. So that means that scale is 2. It doubled in length. Across the top is 2, and again, it shows a scale of 2 as well, because you start with a 1, now you doubled it. Coming down is 4, and that 2 there is double next to 4. Across the next piece is 2, which doubles the 1. On this side here is a 2, it doubles the 1. And for the last one to work, it better be a 4, because you're doubling the 2, which is what, because every length has been doubled here. Across the bottom, it is a 4. So this scale factor is 2, because every length of shape A has been doubled to make shape B. So go ahead and turn the video off and take a look at C through E. See which ones actually are scale copies. If they are, write the scale factor. If not, write not scale. Write no in the blank. Turn the video back on when you're ready. So as I looked at the shapes, you'll notice that in C and D, I didn't put a lot of numbers in because as I work from the top going clockwise, in problem C, the scale factor is 2. I'm starting with a 1 in A, and now doubled. And then when coming down in A is 2, and the length coming down C is a 6, which means that length has been tripled. So they're both showing a different scale factor. So this answer is no. In problem D, across the top is a 3. So since I'm starting with a 1 on A, that's a scale factor of 3. When I come down, it's a 2 on A, it's a 4 on D, which is a scale factor of 2. So I got 2 different scale factors. On the top is a 3, going down is a 2, so therefore not a scale copy. In problem E, if you start at the top and go clockwise, the 1 becomes a 3, tripled, the 2 becomes a 6, tripled, and if you can continue around, every number on A has been tripled to get the length on E. So that means that D is a copy, E is a copy of A, and the scale factor is 3 since each length of A has been tripled. Continuing, we're asking you to draw a loop around the shape that is similar to the given. Similar means that if I take it to, for example, a copy machine, and I would make a copy that either makes it larger or smaller, that what characteristics are not going to change. And so, for example, would A, B, or C, would any of those, in your opinion, be a scaled copy of the given shape? So go ahead and think about those. Circle the ones that you believe work. Turn the video back on when you're ready. So in problem, I'm going to start with problem B. Problem B is kind of squished. So those squares in the given shape are no longer squares here. So if I went to a Xerox machine and I put in a right triangle, for example, made a copy of a right triangle, I wouldn't expect to get back an isosceles triangle as a replacement. Or if I put in a circle, I wouldn't expect to get back a rectangle. I would expect the shape to come back to look exactly like the original, but a little larger or a little smaller, but would look like the original shape. So B is a no. Problem C, for example, the issue here is that those green triangles are in a different location than they are in the given shape. So the only one that actually works is A. So if you rotate it and then enlarge it, you would end up getting that shape. So problem 4 says draw a shape similar to the one shown to the right using scale factor 2. Based on your answer to problem 3, two shapes can be similar, but one of these facts doesn't have to be true. Draw a loop around the fact it's not true. So one thing we're trying to do in this lesson, and this lesson's in 2 parts, you'll get the second part on Tuesday, or on Monday, is we're trying to establish what is always true about shapes that are similar. So at this point, looking back at the L's, for example, or back to the triangles on the first page, that the corresponding angles were the same. So, and the triangle, the A angles were the same, the B angles were the same, the C's were 90s. On the L's, we basically have all 90s or 270s, and it didn't matter which shape I did, those angles were the same, whether they were similar or not. The sides were parallel. So is that always, do you think it's always going to hold true? Or the same shape but the different sizes? So the question we're asking here is, based on what we've done so far, which statement here doesn't appear to be true based on your drawing for number 5? And you may find that you think all 3 of them are true based on what you've done, but I'm going to draw my examples so that we can definitely eliminate one of the 3 choices. When you're finished, turn the video back on. All right, so first question is, in terms of the shape, what appears to be the same and what has not worked here? So I went ahead and tried to draw the shape so that I could make sure that at least one of these things didn't work. So angle A is still a right angle. Angle B looks the same. Use patty paper. If you're not sure, use patty paper and draw the original shape A, B, C, D, E, F, and then try to fit the patty paper in those angles to see if they match up. And if you do that, hopefully you will find that they do match. If they don't match, it probably means that your shape is not a correct scale copy. The shape is definitely the same, but different sizes. The one factor that I made sure didn't work here is that corresponding sides are not parallel. Actually, I made sure that AF, if I went ahead and extend AF down, and if I extend F prime across, what I actually did was I made sure that those 2 segments were actually perpendicular to each other. If I would extend the sides into lines, they would intersect, making a right angle. So the one that doesn't work here is the shapes. The corresponding sides don't have to always be parallel to each other. Angles still got to be the same. The shapes still got to look like they're the same shape. It's just in a large copy or a reduction. Problem 6 and 7, give me a little time here. Can you come up with which shape up here that you believe are similar and draw a loop around it? Problem 7, I've given you a rectangle and I'm asking you to make each side 4 units shorter than the original. And the question I'm posing in number 8 is that are the resulting rectangles scale copies of each other, yes or no? And then, again, based on the 2 things that are left, is there any fact that still didn't work here? And last question is are circles always dilations of each other? So go ahead and finish this page. When you're finished, turn the video back on. So in problem 6, it looks like B and C could be the right answer. B actually is the right answer. C, the problem with C is that the circle with the X inside of it has actually been rotated slightly. So even though it looks like it's a scale copy, it's not because that circle's been rotated. In problem 7, I asked you to make each side shorter by 4. And so are these scale copies of each other? And the answer is no. The reason why is because the scale factor between these 2 here is 2. And the scale factor between these 2 are not 2. So therefore, they're not copies of each other. And so the question here is, so which one doesn't seem to work here? So the corresponding angles still stay the same, but the shapes were not the same shape. They're both rectangles, but they're not different sizes of each other. Last question, are circles dilations of each other, and the answer is always yes. This completes the last page.